Hello, my name is Yan Zun, and today I'm going to talk about the effects of polymer on society and societal needs.
Hello, I'm Lei. Today I want to talk about the technology of polymers.
Yo man, what's up? Leon over here, and I'm talking about polymers in the environment.
Hi, I'm Rashidi, and I'm going to talk about polymers and their application for the medical field.
Hi everyone. Today, me and my members, we're going to talk about polymers. My friend, they'll explain more in details, like in different departments like society, technology, or medical. What are polymers? Polymers are like a chain. Of small particles combined together and form a molecule or something stronger, so that it will be much durable, much flexible, and it's not easily break. And I'll hand it to my friends, and they'll explain more in details.
Polymers can be related to society and societal needs in the form of plastics. Plastic is vital in human lives and in society because of its power to be made into almost any product that we need, its ease of manufacturing, and its low cost production. It means that it's cheap. So one such example of polymers would be polyethylene. Polyethylene is used to make like plastic bags or plastic bottles. The reason it's used to make plastic bags and plastic bottles is because that it has high ductility and it has low friction, which means that, you see, you can't really scratch the surface of polyethylene, and like it is quite flexible and ductile, which means that it wouldn't break easily. The plastic polymer that we can look at is PVC, or polyvinyl chloride. So PVC comes in two forms, the rigid form and the flexible form. The rigid form are used to make water pipes, which is kind of like this. So why are they made into water pipes? Because they are highly resistant to corrosion, which means that they can't corrode easily. However, the weak point of PVC is that it's really weak to heat, which means that if it gets in contact to heat, high amount of heat for a long period of time, it will melt easily, which is why you can see that it's in shady areas instead of like under the sun. So another polymer that can be used to make water pipe is polyethylene, which I mentioned just now, or normally called polyethylene when it is used for water pipes. So for flexible form, PVC is made into electric cables insulator. So electric cable insulator is the one that covers the electric cable so that it doesn't give people electric shock when people get into contact with the cable. And that is about it. So next I'll pass it to Leon.
As environmental performance becomes increasingly important, the development of man-made polymers and their associated benefits as environmental performances become increasingly important, the development of man-made polymers and their associated benefits has become overshadowed by polymers relating to their ultimate disposal. In the light of wider acceptance of polymers for use in high environmental application, I aim to readdress the balance, review the properties and the environmental application of polymers, and discuss the environmental benefits compared to their traditional materials. I also aim to address the issue of polymer durability, recycling processes, to aid the waste minimization of biodegradable polymers. This is intended to introduce the non-specialist reader to the benefits and limitations of polymeric materials from an environmental point of view. Hey Yan Zun, man, what's up?
What's up?
How you doing?
Not bad.
If wood is the world's most versatile natural material, nylon is probably the world's most useful synthetic one. It is a plastic that can be molded into everyday products or drawn into fibers for making fabrics. And its launch in the 1930s truly changed the world. You don't believe me? Let me explain. You can snooze away on brushed nylon sheets until your alarm clock, powered by nylon gear, wakes you up. Hop across a nylon rug or carpet in your kitchen. Maybe eat your breakfast from a nylon bowl, or head to the brushing to brush your teeth with a nylon toothbrush. Hold a nylon umbrella over your head to keep out the rain when you set yourself off to work or school, or if the sun is shining, when you're heading to the beach. Wear your quick drying nylon swimming shorts instead. Feeling adventurous? You could try jumping from an airplane over a nylon parachute. Bring yourself safely to the ground. Those are just a few things that nylon does for our everyday life. What makes this material so amazing? Let's take a closer look. Nylon is a generic designation for a family of synthetic polymers, more specifically aliphatic or semi-aromatic polyamides. They can be melted, processed into fibers, films or shapes. The first examples of nylon, nylon 6,6, was produced on February 28, 1935 by Wallace Carothers at DuPont's research facility in the DuPont Experimental Station. Nylon polymers have found significant commercial applications in fibers, apparel, flooring, and rubber reinforcement in shapes, molded parts for cars, electrical equipment, etc. And in the films, mostly for food packaging. Manufacture. Unlike traditional materials such as wood, iron, wool, and cotton, nylon does not exist in nature. We have to make it in chemical plants for organic carbon-based chemicals found in a natural material such as coal or petroleum. It is also possible to make nylon from renewable materials. Zettel, a type of nylon produced by DuPont, comes from castor oil, so essentially vegetables. The nylon polymer is made by reacting together two fairly large molecules using moderate heat, roughly 285 to 545 Fahrenheit. The pressure in the reaction vessel, called an autocalve, which is a bit like an industrial strength like kettle. One of the starting molecules is called hexane 1,6-dicarboxylic acid, also called adipic acid. And the other one is known as 1,6-diaminohexane, or 1,6-diaminohexane, also called hexamethyldiamine. When they combine, they fuse together to make an even larger molecule and give off water in the chemical reaction called as condensation polymerization. Condensation because water is eliminated, obviously. Polymerization because a big piece, repeating molecules are produced. The large molecule formed in this case is most common type of nylon, nylon 6,6, because the two molecules from which it is made of, carbon-6, carbon atoms. Other nylons are made by reacting different starting chemicals. Usually this chemical process produces a giant sheet of ribbon of nylon that is shredded into chips, which become a raw material for all kinds of everyday plastic products. Let's look at some practical examples of polymers, well, precisely nylon. For example, this rope, which is very strong and very durable, can be used to tie things that are probably heavy, like to tie things on a truck. Or another practical example is this umbrella tent, made of nylon, which keeps rain away from us, the sun, and everything else. Natural polymers and synthetic polymers are totally different. Natural polymers are more rigid, more strong, and are used for like plastic bottles, like polyethylene, for example, which is not biodegradable. Unlike synthetic polymers like spiderwebs. Well, in this day and age, scientists are doing research on spiders because their synthetic polymers are famously known for being flexible and strong. Others are looking more into construction of polymers because of the different arrangement of polymers, which will help us construct polymers that are much more biodegradable and more environmentally friendly, and that can easily fix themselves when we throw them away or when they biodegrade.
Although there are a lot of applications in the medical field for polymers, the most widely used is PVC, or polyvinyl chloride. This is due to its characteristic being flexible and elastic. It is used for containers for blood, urine continence, and ostomy products. It is also used for containers for intravenous solution-giving tests, tubing for dialysis, endotracheal feeding and pressure monitoring, inflatable splints, and so much more. The cost of polyvinyl chloride which is cheap, along with its flexibility, is the reason why it is used mostly in medical applications.
Hello. Today I want to talk about the technology of polymer. Polymer also can connect to the technology to form medicines. So the multiple biological, synthetic and hybrid for polymers are used for the multiple medical application. For example, the polymer, the polyamide, or what society know as nylon, are also used in medical field. Nylon are used as suture material, suturing scar and wounds. So the wounds will be recovered soon and closed up. And nylon also helpful in repair the ligament and tendons. Other than that, polymers are allowed multiple medicals, being the polymer called polyolefins or low density polyethylenes. The short form will be LDPE. Heat shrink tubing benefits to medical device and application in many ways. For example, by serving as protective recovering, as insulation for electric wires, or by adding with component, bonding, and manufacturing. Other than that, polyethylene, based on the heat shrink tubes, it's capable of high shrink ratios, low recovery temperature, and good surface lubricity. Polyethylenes also offers distance advantage for heat shrink tubing. It is ideal material for use to transition tubing, electrodes, and other applications. So that require extreme flexibility, thin wall, and low temperature shrink. So this makes the nylon, the polyethylene, polyolefin is popular in this society. And it's convenient to take, and then it is cheaper, and then won't cost.
Oh, I don't know. Okay, we can do that for it. Yeah, man, you're gonna do it. You have to do a lot of cutting.
So guys, I think that's it for the video, and yeah, see you in the next one.